Logarithmic equations, again, just like the exponential ones, you have to first check if there is a logarithm on both sides or on one side. I think it's easier, or let's first do the case where there is a logarithm on both sides of the equation. Okay? If you have that situation, you set the arguments equal to each other and you solve. Okay? So for example, if you have, log base 3 of x is equal to log base 3 of 5, you see how everything is the same, right? You have log base 3, log base 3. So that means this inside has to equal that inside. So you just say x is equal to 5. All right, just set the insides, the arguments equal to each other. One thing you have to be careful of is if there is 2 or 3 logs on one side, you have to condense the logarithm so that there is only one log on each side. And then because logarithms don't have a domain of all reals, you have to check for extraneous solutions. All right, so let's take that first case and then we'll go back. So let's solve this logarithmic equation here. Look at this. I have log base 3 and log base 3. They're the same. They're identical. That means I can set the insides equal to each other. So I get 5x minus 1 equal to x plus 7 minus x minus x. 4x minus 1 is equal to 7. Add 1. 4x equals 8. 8 is equal, x is equal to 2. Okay? And then here, you have to check to make sure that you did it, that this is the right answer. So you put it back into the log. Log 3, 5 times 2 minus 1. Is this equal to log base 3, 2 plus 7? Okay? And you see here, I get log base 3, 10 minus 1 is 9. Log base 3 of 9, that does equal log base 3 of 9. Since you get the same thing on both sides, this works. Okay, same thing here. I have log base 2, log base 2. I'm going to set these equal to each other. So I'm going to get 2x equal to x minus 2. Subtract x, and I get x equal to negative 2. And now let's go and check. I get log base 2, 2 times negative 2, right? Equals to log, but look at what happens here, right? What do I get there? Log base 2 of negative 4. Is that allowed? That's not allowed. So that doesn't work. So you say no solution. Okay. All right. Next one. Okay. So the next one has 1 log, right? Not 2, just 1. So what we're going to do is I'm going to give you a different method here. So what we're going to do is first isolate the logarithm. So divide by 2, divide by 2. And I get ln of x is equal to 9. And so what we're going to do here is we're going to use that property that a logarithm is just a what? An exponent, right? So that means this 9 here is an exponent, correct? Okay, every exponent needs a base. If my logarithm is an ln, what is the base? What's the base of an ln? E, right? Base is ln. So I say e, well, e to the 9 is equal to x. Okay? Let's do, is everybody okay with that? Let's do one more here. Let's subtract 7. Negative 3 log 10x is equal to 6. Let's divide by negative 3. I get log 10x is equal to negative 2. Okay, now that my logarithm is isolated, what is the base of this logarithm? 10. Right here, I have a base of 10. Every base needs an exponent. That's the exponent. So I say base to the power of negative 2 is equal to basically what you haven't used, 10x. Okay? So now I divide by 10. I divide by 10. So x is 10 to the negative 2 over 10, which is what? It's 10 to the negative 3. Because you subtract, right? This has an exponent of 1. So it'll be negative 2 minus 1. So x is 1 over 10 cubed, which is 1 over 1,000. Let's do that again, yeah? I know.
Why is 10 to the power? Why do you take the base and put it to the power of negative 2?
Well, because that's how you solve it. So remember what we said is, if I have log base 5 of x is equal to 7, right? If I have this is a base. This is an exponent, right? So another way to write this is x is equal to the base, to the power of the exponent, right? So here, base is 10, exponent is negative 2. So I say this blue 10x is equal to the base to the power of the exponent. And then I need to solve for x. Divide by 10, divide by 10. Now technically here you've solved for x, but you just have to simplify that a little bit. So how do we work with negative exponents? Negative exponents always move down. Another thing you could have done is this. If you have x equal to 10 to the negative 2 over 10, another thing you could have done is this 10 stays here, and then this with a negative exponent moves down. So you have 1 over 10 cubed, which is 1 over 1,000. Okay? So both of them are okay. All right, let's do one more. All right, let's do one more. Here I have, okay, my logarithm is isolated. A logarithm is just an exponent. That means this is an exponent. Well, every exponent needs a base. This is the base. So I say 5 to the power of 20 is equal to x to the 4. Okay? So now, how do I get rid of x to the 4? How do I get rid of that exponent? What do I do? To the power of 1/4. Absolutely. So to the power of 1/4, to the power of 1/4, and I get x equals 5 to the power of 20 over 4, 5. And rule of thumb, if your value exceeds 3 digits, like if it goes into the 4 digits and above, just leave it like this, okay? But if you get something like 3 cubed, which is 27, write it out. Okay, take a look at this one. Now we're putting things together. Log base 5, log base 5, I set the insides equal to each other. So I get x squared plus x is equal to 20. And now it's just a quadratic equation. X squared plus x minus 20 is equal to 0. Can we factor this? x plus 5, x minus 4 equal to 0. X equals negative 5, x equals 4. So one thing I've not been doing is I haven't been going in and checking every single time. When you get a negative, it's always important to check, especially when you get a negative answer or when you get two answers, it's important to check. So why don't we go ahead and check these two, see if they work. Let's check x equals negative 5, right? What does that give me? Log base 5. I'm plugging it into here, right? If I have negative 5 squared, 25 minus 5, is that equal to log base 5 of 20? That is, so that works. And now let's do x equals 4. Log base 5, x squared, 16, plus 4. Is that equal to log base 5 of 20? It is, so both of these are answers. All right? Okay, this next one, look here. I have one log on this side, but look at this. I have two logs over there. I need to condense this. So I'm going to make it log base 2, 10 over x minus 4. And now set them equal to each other. So what do we do now? Yeah, multiply by x minus 4 on both sides. So 5x minus 4 is equal to 10. Distribute. Add 20. 5x is 30. X is 6. All right. Now, when you want to check, you can plug it into either here or here. And so let's see. Let's plug 6 into the one that we condensed. I'll get 10 over 6 minus 4 is 2. So I'll get log base 2. 10 over 2 is 5. Log base 2 of 5. So that does work. All right? All right. The next one, I need to condense this. So I get log 3x, x plus 2 is equal to 1. Okay. Now I only have a logarithm on one side. So I got to do base exponent. The base of this logarithm is 10. So this is going to equal 10 to the 1. That's the exponent here. And what does that equal? The stuff inside. 3x, x plus 2. Okay. Distribute. 3x squared plus 6x equal to 10. Bring in the 3x, the 10. Now what? Does that work? Are you sure? Huh? So x is negative b plus or minus the square root b squared, minus 4ac over 2 times a. Okay, so did we get to this point? So now this is negative 6 plus or minus the square root of 156 over 6. It's 2 negative, so it becomes a positive. So let's see how we can factor the 156. It'll be 2 times what? 78. And that's 2 times 39. So this will reduce to -6 plus or minus 2 root 39 all over 6. And now I can divide everything by 2. So it's -3 plus or minus root 39 over 3. Okay? No, you can only cancel out if you can divide by the same number in all 3 terms. All right, let's do one more. We're going to condense this. So we're going to get log base 4, x plus 10 is equal to log base 4, 3x. Insides equal to each other. You guys mind if I distribute first? So I get x squared plus 10x minus 3x is equal to 0. I skipped too many steps there. Did I? You guys okay? You're good? Okay. So can this be factored? It's x squared plus 7x equal to 0. I can take out an x plus 7 equal to 0. Okay, let's plug some of this stuff in, right? X is 0, x is -7. So let's check. X equals 0. Does that work? I get log 10 plus log of 0. Can I get log of 0? Log of 0 is not allowed. So x equals 0 doesn't work. How about x equals -7? Here I'm cool. Log of whatever, 3. But then log of -7 equals to log of -21. I can't have log of a negative number. So that doesn't work either. That means no solution. Okay.
So how is it checking if like it can be wrong and this way no solution?
Well, that's why you check, because these are extraneous solutions. Remember how when we had like
yeah, but like you're not checking to see if it's right, you're checking to see if it's no solution or not.
Well, checking to see if it's right. So okay. So when you're checking, 2 things can happen. Either the answer will give you like equal values on right and left, or it doesn't give you equal values, or it gives you something that's undefined. Just like when we had restrictions before, when you had like, 3x over x minus 1, right? And you had a restriction and it didn't work, that would have been no solution. So the thing is, if you get 2 solutions, one could work, or both could work, or none could work. All right? Okay. Let's do this one quickly. Set equal to each other. 2x squared minus 10x plus 8 equal to 0. Divide everything by 2. X squared minus 5x plus 4 equal to 0. Right? And then this factors as x minus 4, x minus 1. X is 4, x is 1. All right, so let's check. X is 4. I plug it in here. What do I get? Log base 2. 2 times 16 plus 1. Is this equal to log base 2? What happens if I plug a 4 in there? 40 minus 7, 33. Does that give me 33 on this side? 2 times 16 plus 1? It does, so that works. Well, what about x equals 1? I get log base 2 of 3. Does that equal to log base 2 of 10 minus 7? It does. So they both work. Yeah. Okay, so look, if you get ones like this here, like H, it's mostly gonna work, right? I would check if you get either a negative or if you get two solutions. No, but so here's the tricky thing. If you haven't checked and if it was no solution, yeah, then you would. Okay, so go ahead and do this very last one. J is a repeat, so we're going to cross it out. But go ahead and do K, please. I'll give you like a minute and a half. I'll pause this too. So did everybody get to this point? Where do we go from here? Does that factor?
No.
No, so we have to do the quadratic formula. So we get x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So I get x equals 4 plus or minus the square root of 16 plus 16 over 2. So x is 4 plus or minus the square root of 32 over 2. And what's root 32? How many 2's in 32? 5 2's. So this will be 4 plus or minus. 4 will come out. 1 2 will stay over 2. And then I divide everything by 2 and I get 2 plus or minus 2 root 2. All right? So the homework for this is the last handout, and then we're going to start to review.